Hey, Math 20-1s. Today we're going to look at solving quadratic inequalities. So step one, let's understand what inequalities are. With inequalities, we have signs like greater than and less than, and they're going to relate to expressions. So you've got this setup here. I want you to do the operations on both sides of 10 is less than 15. Always go back to 10 is less than 15 and record the result in the first column, and then state whether the result is true or false in the second column. So you're going to add 5 to 10 and you're going to add 5 to 15 and state the inequality. Then you're going to subtract 5 from 10 and subtract 5 from 15 and state the inequality. So I want you to pause the recording and do that for a few minutes and then come back and see the completed table. So what you should have noticed is this is what the table should look like. And we should find out that working with inequalities is identical to working with regular equations unless we multiply or divide both sides by a negative. Then our statement changes. All right, what used to be true, as soon as I multiply it or divide it by a negative, becomes a false statement. All right, so if both sides of an inequality are multiplied or divided by a negative number, the inequality sign is reversed in order to keep the inequality a true statement. So that's something really important to remember. Graphing linear inequalities on a number line. So let's say you're asked to solve and graph x plus 8 is greater than or equal to 2 minus 5x. We're going to treat this just like it was a regular equation. So I want to try and get all my x's together. So I'm going to add 5x to both sides, bring that to this side, and I'm going to subtract 8 from both sides. So my next step would look like this. X plus 5x is greater than or equal to 2 minus 8. Now we simplify it. So 6x is greater than or equal to negative 6. And I simply divide both sides by 6 now. So x is greater than or equal to negative 1. So nowhere in solving this inequality did I multiply or divide by a negative, so I did not have to reverse my sign to make sure the inequality stayed true. All right. Now how do I graph x is greater than or equal to negative 1 on a number line? Well, you find negative 1, you put a closed dot on negative 1 because negative 1 is part of the solution. Negative 1 is greater than or equal to negative 1, and then all the numbers greater than negative 1, so you make a solid line and an arrow to the right. So the solid dot indicates negative 1 is part of the solution. So x greater than or equal to negative 1 means x is greater than negative 1, and it also means x equals negative 1. And that is what the solid dot represents. Let's say you're asked to graph linear inequalities on a number line, and this is what it looks like now. So if we go ahead and solve this one, step 1 is to expand out this bracket. So we get 2x plus 6, subtract 5x is less than x minus 10. Let's combine like terms on the left side. So 2x minus 5x, so negative 3x, add 6 is less than x minus 10. And now we're at the same step we were with the inequality from the last slide. So I want to move this x to the left side by subtracting x. I want to subtract the 6 from both sides. So I get negative 3x minus x is less than negative 10 minus 6. Simplify both sides. Negative 4x is less than negative 16. And finally, divide both sides by negative 4. I am dividing both sides of an inequality by a negative. So in order to keep this inequality true, I must reverse the sign. So if I divide the left side by negative 4, I get x. If I divide the right side by negative 4, I get 4, but my inequality becomes greater than. So x should be greater than 4. I divided by a negative. We learned that earlier. If you divide by a negative, you must reverse the sign to keep the inequality true. All right. Now if I want to graph this on a number line, 4 is no longer part of the solution. It must be values greater than 4. So this is not equal to 4, it's just a greater than sign. So to graph that on a number line, I would put an open circle on 4, and that indicates 4 is not part of the solution, but the number right after 4 is. So 4.001 is greater than 4, and 4.000001 is greater than 4, but I can't really graph that on the number line. So we put an open circle, and everything to the right of that open circle will indicate the solution set. Let's say you're asked to solve a quadratic inequality by graphing. So for example, solve x squared plus x is less than 20. So step one, write this in standard form. In other words, solve it for 0. Minus 20 from both sides. So you've got this inequality. And then what I want to do is graph this as a function. So x squared plus x minus 20 is going to equal f at x. All right. So if I graph this function, here's what it looks like. So here's the graph of x squared plus x minus 20. All right. Y equals. So that's our function. F at x equals y equals. You need it in your graphing calculator. And now if I look at the inequality, the solution to this is where is this function less than 0? So if I look at the graph, here's where the function equals 0, the x-axis. The y value is 0 right here. So where is it less than 0? That's this whole section of the graph, everything below the x-axis. All right. So the interval where the function is less than 0 is when the graph is below the x-axis. All that stuff. That makes this inequality true. So what values of x satisfy this inequality then? Well, x goes from -5 to +4. Any x value that is from -5 to +4 indicates this graph is below the x-axis. All right. So how do I state that? Just like that would be fine. You could say the solution is -5 is less than x and x is less than 4. Or you could write it as a complete statement. Something like x such that -5 is less than x, which is less than 4, and x is any real number. So any value for x that is between -5 and +4 will satisfy the original inequality. And we found that by graphing the function and seeing when this inequality is less than 0. Let's say this inequality is now x squared plus x is greater than 20. Do the same things. Let's set this inequality equal to 0 and then graph the resulting function, x squared plus x minus 20. So again, we've got that exact same graph, but now we want the inequality that is greater than 0. So we're looking for the interval where f of x is greater than 0. So that's all the x values that are above the x-axis. All right. So that section of the graph. And again, those points go forever. Right. So now we want the values for x that are less than -5 or greater than +4. And that's going to give us values in the original inequality that satisfy. So the solution should be -5 is greater than x, or x is greater than 4. Or you could write that as a single statement. X such that -5 is greater than x, which is greater than 4, and x is any real number. Now, if you don't like solving these by graphing, we can also solve these a couple different ways. We could solve using test points. All right. So let's say we want to solve this inequality. -8x is less than or equal to 3 times x squared minus 1. I'm going to rearrange the inequality so that one side of this is equal to 0. So I'm going to expand this thing out, and then I'm going to add 8x to both sides. So 3x squared minus 3, and I'm going to also add the 8x to the right side. So 3x squared plus 8x minus 3, and the left side is 0. So 0 is less than or equal to that quadratic. Now I want to factor this quadratic. All right. So if I factor the right side of this, we should be able to do that. If you remember, rewrite it as a quad equation first. So 0 is going to equal this quad equation. And then we're going to solve by factoring. So we've done this already. This is a unit we've already completed. So we factor 3x squared plus 8x minus 3 as x plus 3 times 3x minus 1. Now if we solve this, we get x equals -3 and x equals positive 1/3. Nothing new there. So from this step to the solution, nothing new there. How does it apply to an inequality? Well, these points that we solved the quadratic equation for are called critical points of the inequality solution. All right. So let's identify those critical points. They're at -3 and 1/3. Now, in order to figure out what the solutions are, we've got three intervals here. All right. So there's the interval where x is less than or equal to negative 3. So that's this whole section. We've got the interval between negative 3 and positive 1/3. And we've got the interval where the values are greater than or equal to 1/3. So that breaks up all the possible numbers based on the critical points that we got from this quadratic equation. All right. So in order to solve the inequality, we have to choose some test points and see which intervals are actually true for our inequality. So we're going to do that in the next slide. All right, so we're going to choose test points in each interval and see if it satisfies the original inequality. So there's our original inequality. For the interval x is less than or equal to negative 3, well, choose any value less than negative 3. So I mean negative 4 works. Any value less than negative 3 works. So let's plug in negative 4 for x here. All right, so negative 8 times negative 4 is 32. Negative 4 squared is 16 minus 1 is 15 times 3. This should be 45. There we go. So that point should be 32 is less than or equal to 45. This is a true statement. 32 is less than 45. So that is going to be a good interval. X is less than or equal to negative 3. Any point less than negative 3 seems to work in the original inequality. Let's choose the second interval. X is between negative 3 and positive 1/3. So the easiest number between negative 3 and positive 1/3 would be 0. 0 is a very easy number to work with. So I plug 0 in for x. Negative 8 times 0, less than or equal to 3 times 0 squared minus 1. That means 0 gives us 0 is less than or equal to negative 3. Well, that's not true. That's a false statement. So we know this interval will not work for satisfying the inequality. And let's do a test point in the final interval. X is greater than 1/3. So let's pick any value greater than 1/3. Again, any number will work. A nice simple number is the number 1. So I plug 1 in for x. Negative 8 times 1 equals 3 times 1 squared minus 1. And we come up with negative 8 is less than or equal to 0. Again, that's a true statement. Negative 8 is less than 0. So that's a good interval. So now that we know the good intervals that satisfy the inequality and the bad ones, we will state the good ones as the solutions. So the solution to this inequality is x is less than negative 3 or x is greater than or equal to 1/3. And again, we could state that as a single statement. X such that negative 3 is greater than or equal to x, which is greater than or equal to 1/3 and any real number. There is yet a third method to solve inequalities if we want to use sign analysis. And we're talking about signs, we're talking about positive and negative signs now. So if you're asked to solve the inequality 3x squared plus 2x is less than 1, we're going to do the same thing we did for the test point method. We're going to set one side equal to 0. All right, so let's say 3x squared plus 2x minus 1 is less than 0. Now we're going to rewrite this as a quadratic equation and solve by factoring yet again. So nothing new. So as a quadratic equation, it's 3x squared plus 2x minus 1 equals 0. And if I solve it by factoring, again, we can factor the left side of this quadratic equation to be x plus 1 times 3x minus 1. So that's a skill we expect you to have at this point. Now solve this quadratic equation. We get x equals negative 1 or x equals positive 1/3. So therefore, the critical points for the inequality solutions are x is negative 1 and x is 1/3. Now, when we did intervals, we figured out the test points for certain intervals. What we're going to do now is we're going to list in a table appropriate values for x in each interval and determine the sign, whether it's positive or negative in each case. All right. So solving by sign analysis, we've got three intervals again. The intervals are x is less than negative 1, x is between negative 1 and 1/3, and x is greater than 1/3. So just like with test points, we got to figure out what those three intervals are. We're not going to pick a value for x that lies in that interval, so let's pick a value for x that is less than negative 1. So if x is, say, negative 10, that's definitely less than negative 1. Let's plug it into these factors, all right? Or you could plug it back into the original inequality, whatever you like, all right? So if I plug in negative 10 here, I get negative 30 minus 1, or negative 31 times negative 10 plus 1, which is negative 9. Well, that's going to be a negative times a negative, which is a positive sign. And that's all we're worried about. If I pick a value between negative 1 and 1/3, again, that easy value is 0. If I plug 0 in for x, I get 3 times 0, which is 0 minus, subtract 1, and 0 plus 1. So a negative sign times a positive sign is a negative sign. And if I pick an x value that's greater than 1/3, 10 is nice and easy. 30 minus 1 is 29, and 10 plus 1 is 11. So positive times a positive is a positive. So with sign analysis, if we remember what we're trying to do, we're trying to solve this inequality. 3x squared plus 2x minus 1 is less than 0. All right. The interval we want a sign that's a negative sign because we want this thing to be less than 0. Obviously, positive signs would be greater than 0. A negative sign means it's less than 0. So the only interval that's going to satisfy this inequality is between negative 1/3 and positive 1, or sorry, between negative 1 and positive 1/3. So that's the interval we want as a solution. All right. Therefore, the intervals where the sign is negative are between negative 1 and positive 1/3, and that's how we'd write that solution. Excellent. Here's your assignment. We want you guys to come to class tomorrow and be ready to work on that, and have any questions you may have ready about the notes. We can ask those then. We'll see you then.